3, 2, 1, may I start? Very good afternoon, dear friends. Welcome back to the VCC, and we are taking up today the last part of the time value of money. So in the last two sessions, we have covered in details what is the concept of time value of money. We have gone into discussions of present value, future value, and annuity. You remember we have done numericals on annuity due, which is also known as annuity immediate, and we have done annuity regular. In case of annuity regular, you remember that the first payment takes place at the end of the period, but in case of the annuity due or annuity immediate, we take the first payment at the very beginning. That means when time is zero, immediate. That's why it is also called due or immediate. Well, we are now taking up today the third part, which is on the applications of the time value of money. So in the last session, we did questions on sinking fund, on annuity, and today we are taking up some of the practical applications of the time value of money. And this is in regard to, I'll write apps. So the applications, number one will be in case of leasing. Number two, in case of bond valuation. And you remember last day we were talking about return, risk, and we have also discussed about shares, bonds, debentures. Well, today we are taking up how to do valuation of bond using the principles we have learned so far. So let me write bond valuation, which is also there in the study material. And we will take up capital expenditure. This is very important part. I'm writing CAPEX in short, capital expenditure. Friends, we shall also learn one more point, and that is the concept of nominal rate of return and real rate of return, right? I will write here rate of return. Okay, first is nominal, and then the real rate of return. Okay, so we will discuss both of them, the nominal rate as well as the real rate of return. Then, yes, we have a discussion on something which is called CAGR, which expands to compounded annual growth rate, right? So say a company's sales is increasing from, say, certain amount to certain amount, from A to B. So what is the growth rate which they are achieving over 1 year? Okay, so we will see compounded annual growth rate, and definitely we will do more problems from the exercises B, C, D, and the additional question bank, right? So we will have more questions and solution we will do. Okay, so that is the plan for today. Today being the last session on the time value of money. On the next day, we will take up permutation and then combinations. Fine, so I think you are all set and you have pen and paper ready with you. So here we go. Quick recap of some of the key points. We did questions on 2-3 important formulas. You remember that the difference between the compound interest minus simple interest for 2 years, right, is P into I square, where P is the principal and I is what? I is the interest rate. And the same difference between the compound interest and the simple interest when you have 3 years. So this is for 2 years, but for 3 years, the same difference will be compound interest minus simple interest. That will be equal to 3 into Pi square plus Pi cube. So this is something we have discussed, and we will do some problems on that. Plus, we have seen that the present value of a future, say for example, this is V is an amount given which you will be getting after, say, n number of years, and the interest rate is I. So the present value will be equal to V divided by 1 plus I to the power n. So PV means the present value. So we shall take up some very interesting areas in this chapter. First, we will take some questions from the study material and we will solve a number of them before we go on to the applications. Of course, in the applications, we have leasing. Leasing is nothing but a sort of renting out of property. bond valuation, then we will take capital expenditure, we will take the difference, we'll understand the difference between the real rate of return and the nominal rate of return, and then we will move into the last part, which is the compounded annual growth rate, or CAGR. So let us do some problems and further work on the exercise. So I'm taking exercise 4B, number 6. Exercise number 4B, number 6, and I think this is page 4.20, 4.20 as per the study material available with me. Now let us see the question. The population of a town increases every year by 2% of the population at the beginning of that year. So increase of the population per year, okay, increase per year is 2%. Now 2% means 0.02. So let me write 0.02 directly. Fine. The number of years we have to find by which the total increase in the population will be 40%. This is what we have to find. So every year, the population of the town increases by 2% of the population at the beginning of the year. So you see, this is like a compounded rate, right? So I was talking about, we discussed about written down value where you have a compounding. Similarly, we talked about investments like public provident fund and mutual funds where the interest gets compounded, right? So here again, you see 2% increase. So first year it is 100, say, next year it becomes 102. Then the next year it will be 2% of 102. And so on, it will go on and on, okay? So we have to find in how many years the population of that particular town will increase by 40%. 40% increase. I am showing an upward arrow to show that it is 40%. Okay, so this is the question. The original population we will take as P. So we'll try to solve it. Solution. So let P is equal to the population at the beginning. Okay, so I'm writing population at the beginning. Now the new population will be 40% increase in the original population. That means the new population will become 140%. So 40% above. So it is 140%. Okay. So which also means this is equal to nothing but, can I write 140% as 140 by 100? So this is 1.4. So it will become 1.4 times of the original population. The original population is P, so the new population becomes 1.4 P. Okay, so this is we are working out the new population after the increase takes place every year and so on. So at the same time, we know the formula for compounding, and here we can see that the population is increasing by 2%, which is compounded annually, right? Very similar to interest of 2% compounded annually. What is the formula? Just recall. So can we write that we of course don't know, friends, in how many years the population will become 40% of the original population. So let us take the number of years. The number of years we will assume as n. Okay. So let me frame the equation. So the new population is 1.4 times of P. This will be equal to the original population P into 1 plus 0.02 to the power n. Original population, think of the compounding formula. Original principal into 1 plus interest rate to the power n. Here also, instead of interest rate, we have the increase in the population of the town. So P is the original population, 1 plus 0.02 to the power n. Here 0.02 means this, we have this 2%. 2% is here. N is the number of years in which the population will become 40% higher. That means it will reach 140% of the original population, right? I hope you're following and it's clear. So this is the equation. So what we do is P and P cancels out. So I'm getting now 1 plus 0.2 means how much? 1.02. So I can write 1.02 to the power n will give 1.4. 1.02 to the power n. This 1 plus 0.02 means 1.02 to the power n should give me 1.4. Please see that P and P have got cancelled out. Now from here, we have to multiply. If log table is given, you have done logarithms. I'm not going into that. Sometimes log table is given. So if you use logarithms, yes, you can find out. Otherwise, you have to multiply 1.02 and see what is the value of n. Now, if you go on doing it, you will find as per the problem, n will come to 17. So it is 17 years. In 17 years, the original population P will become 40% of, will register a growth of 40%. But of course, there is a compounding of 2% of the population getting increased every year. Okay. So in this way, we are able to solve it using the simple formula of compounding. Okay. Yeah, we will do present value. Don't worry. Some of you are writing about present value. We will do that. Present value, we will see. Okay. And we will do number of problems on that. Okay. So this is the first problem we have done. Now, let me take the other next question. Okay. I'll take the questions once again. Okay. So we remember we have done the recap, okay, of the first formula, which is the compound interest minus simple interest for 2 years, which is how much? Pi square. For 3 years, it is 3 pi square plus pi cube. That is first thing which you remember. Yeah, you have to think that, yeah, am I remembering? Yes, you are remembering slowly but steadily. Second is we saw the compounding interest formula, right? The amount is always equal to principal into 1 plus I to the power n, right? Where I is the interest rate, right? And n is the number of years. This is the formula for compounding, okay? And then we have seen one more formula, which I think you remember. I'm just doing a recap, effective rate of interest. And we saw that this is how much? 1 plus I to the power n minus 1. That gives you the effective rate of interest. And then we have seen the annuity formula, annuity regular, R, annuity regular, which means at the end of the accounting period. The first payment takes place at the end of the accounting period. It can be month, it can be year, okay? And of course, this is something we have discussed, especially in case of loans taken from a bank. It can be the monthly installment, it can also be yearly payment, but of course, we talk about an accounting period, month or year, whatever. So the formula, you remember, was that A into 1 plus I to the power n minus 1 divided by I. This is the formula. We are doing a quick recap, and many of you, I think, will get benefit. For example, Amit was writing that please requesting me to do a recap. So I have started already with the recap. So you can see this is the first formula we learned. Of course, before that, one more formula was there. Amount is equal to principal plus interest. And this interest is nothing but principal plus principal into interest rate, small I into time. So this was the very first formula we started with. Then we had the compounding interest formula. The first one, of course, is, you can see it is simple interest. The second one is the formula for compound interest. The third formula is the effective rate of interest. The fourth formula is the annuity regular. And the fifth formula is the annuity due or the annuity immediate. So I'm writing annuity within bracket due. And this formula is A 1 plus I to the power n minus 1 by I into 1 plus I. Right, and this is the 5 formula you can see, and of course 2 more which you all know, and that is the difference of compound interest minus simple interest for 2 years, and the difference of compound interest minus simple interest for 3 years. That's it. Nothing else is there. Fine. Fine. Okay, Ishika, there's a question how to know whether it's, the question is asking us to find out annuity due or is it annuity regular. Now, they will tell you in the problem, if the problem goes like this, that you say that the problem is like this, that Mr. X receives a payment of 10,000 every year, and the first payment is received immediately. So this is what the word immediately, it will strike in your mind that the word immediately means it is an annuity due or an annuity immediate. Okay, another example, say the numerical, we will do these problems today. Say the numerical says that you are receiving a gift from your father, and the gift is 5,000 rupees every year, and the first installment you will be getting at the end of the year. So this is simple. It is an annuity regular problem. So please, Ishika, please see the language of the problem and you will understand whether it's annuity due or annuity regular. In most of the cases, I think problems will come on annuity regular. So, but that means that you need to always remember both the formula. Okay, right. Let me take some other problems. Archana was asking in the last problem how 140 comes. Archana, she is from Karnataka. Archana, I think you will understand that. Let me rub out these formula. This is all in front of you. It's a quick recap because today being the last day on time value of money, we have done a quick recap of all the important formula before we move into the applications. Now, in the last problem which I solved, yes, Archana is asking how 140 comes. Now, the original population is, say, 100. Okay, very simple, Archana. Original population is 100. The problem says that the population increases by 40%. So what is the increase? The increase is by 40%. So 40% of what? So the increase is 40% of 100 into the original population of 100. Okay, so the increase is how much? 40. So the new population is how much? The new population is 100, the original one, okay, plus this 40, plus 40, which is 140. I hope, Archana, it's clear now. Okay. Pooja Kumari from Delhi also, how you got 140%. I think, Pooja, you are clear now. I hope it's clear. Right. Acha, Supradha from Chennai is asking, will log table be given in the exams? Yes, I think log table is given because you will have to solve a lot of problems, and log tables are provided. If you want in the exam, they will provide you with a log table. Okay, then it will be easy for you to solve. Okay. Yeah, thank you, Amit. Okay. Okay, I'll go to the examples, then I'll come back to the questions again. Now, friends, we are taking one question on compound interest, right? And this is from, this is a past exam question. So, very simple question. What is the compound interest on 4,000 rupees? So, you have to find the compound interest, question mark, on rupees 4,000, okay? And the interest is 12%. Achha, for 6 months. Okay, please note the time, for 6 months at the rate of 12% per annum. At the rate of 12% per annum. And it is payable quarterly. Okay, payable quarterly. Okay. Looks pretty complex, but then we will break it up. Compound interest, fine. You know the difference between compound interest and simple interest. Okay, it's given, principal is given 4,000. Okay, next is the time is 6 months. So on rupees 4,000 at the rate of 12% per annum, if the interest is quarterly compounded, quarter means 3 months. Okay, if the interest is compounded on a quarterly basis, then the original amount, sum of 4,000 rupees, right? That's the original principal. How much will the interest be in 6 months? Okay, so let's work it out together. Hope it's clear. Now, the annual interest, this is an exam question, so very similar question can be expected. Okay, and therefore, let us write, my dear friends, the yearly interest is how much? 12%. Since the interest is compounded quarterly, please see the word quarterly. Quarterly means how much? Quarterly means there are 4 quarters in a year, right? 3 months make a quarter. So there are 4 quarters. So if the yearly interest is 12%, I can write the quarterly interest will be 12% divided by 4, which is 3%. Okay, so I'm writing 3%. 3% means, okay, I should not tell you, you can understand 3 by 100, which means 0.03. Clear up till now? Now we have to find the formula for compound interest. And all of you know that the formula for compound interest basically is principal 1 plus I to the power n minus 1. This is the formula for compound interest. And I will put the values of these given data. I will put the data here and see what I get. Now, please note that I have got an interest of 3%, which is quarterly interest, right? So 3, I is 3, no question about it. I is 3, which means 0.03. No doubts about this. But then we have n. What is n? N is the number of conversion period. It is given that I have to find the interest for 6 months. So the compounding is done in 3 months, and I have to find the interest for 6 months. So n is how much? N is 2. 1 quarter, 2 quarter. First quarter interest is compounded, and then second quarter. So we have n equal to 2, right? Because 6 months divided by 1 quarter is how much? 3 months. Divided by 3, that is 2. Okay, if it was mentioned over 1 year, then it would have been how much? 12 divided by 3. So n would have been equal to 4. But in this problem, my dear friends, n comes to 2. So let me put n equal to 2 and see what result I'm going to get. Now, principal, you know P, what is P? 4,000. I'll write 4,000 here. And 1 plus I. I is how much? 0.03. So I am writing 0.03. N is 2. So square minus 1. Right? So let us solve it and see. Let's calculate and see. So we have 4,000. 1.03 square minus 1. So let me use my calculator and see what I get. Fine. Please calculate with me and see. 1.03 into 1.03. Yes, 1.0609. So I'm getting this is equal to 4,000 into 1.0609 minus 1. This minus 1. So this is equal to 4,000 into 0.0609. How much is that? Let's see. 4,000 into 0.0609. I'm getting 243.6. So the compound interest is 243.6 rupees. Okay. This is an exam question, and I guess it is also there in one of the exercises. Just have to find out. It's there in one of the exercises. I remember doing it earlier as well. So you see here we have just used the compounding formula, and what we have done is we have seen the annual interest, we found out the quarterly interest, and from there we found out the number of conversion period, which is 2 in this case, and then straight away you apply the formula to get the answer. Right. We now go on, my dear friends, to the second one. Next question. Yeah, 243.6. Ritik, Pooja, and Pooja 4243.6. Acha, you are talking about the amount. Yes, 4243.6. Pooja is the amount, and then you deduct 4,000. So you get 243.6 as the interest. Shambhavi Pandey also has got it correct. Yeah. Neha Saraugi 243.6. Vishwabandhu Mohanty, very good. Vishwabandhu Mohanty, you have said 4243. 4243 is the amount, right? But the compound interest is what? Principal plus compound interest gives you the amount. You have got 4243, which is basically the amount. But from there, you have to deduct the principal so that you get the compound interest, right? Fine. 243.6. Yes, Suprada, thank you. Many of you have got it. Pooja Gajjar has got it. Priyanshi has got it. Very good. Excellent. Anushka, you are asking that where is given the original population was 100. So you have to assume if the original population is 100, it becomes 140%. It is clearly given. 40% means what? It is on 100. Okay. So please try to understand that if it is given that, say I'm giving a simple example that say there is, I have some money and the money increases by 25% next year. I have some investment and it increases by 25%. So I have to assume that if I have 100 rupees today, next year it becomes 125. That's how you arrive at the ratio. Okay. Good. I think you can understand now. Right. Arvind, you are asking about how we are getting 17 years. See, the log table will be given. Otherwise, you have to go on multiplying till you get that particular answer. You have to go on multiplying, right? But I think in most of the cases, you will get log table. Otherwise, you have to go on multiplying that 1.02 or 1.03 to the power n. You have to go on multiplying till you get the answer. Okay. Right. Simran asking, paper will be subjective or objective? It will be objective. Yes. Right. Okay. Let's go on to the next one. This is exercise 4B number 13. Many of you might already have written to me regarding solving this problem. So I'm doing it. 4.21, page number 4.21. And the question, let me see, is exercise 4B number 13. Exercise 4B number 13. And the page number is, I think, 4.21. Please see the question. The annual birth rate and the death rate is given. So in every 1,000 of population, per 1,000 people, the birth rate is given. The birth rate. You have to understand this problem carefully, step by step. The birth rate is given, and the birth rate is how much? 39.4. And the death rate comes to 19.4. Fine. Now the question is the number of years in which the population will be doubled. This is something you have to find out. So the population will be doubled in how many years? A beautiful question. Very beautiful question. Okay, Anushka was saying why we took 100. Now Anushka will again get more confidence and clarity as we solve this problem. Okay, let me see. Sudhish, what is your question? Let me see. Sudhish, I'm trying to see your question, but what is the original question? We asked for PPF in our neighbor bank. The bank manager said it is something pension scheme. No, it's public provident fund. You just see, so these just Google it out. Public provident fund. It's not a pension scheme. Okay, fine. Yeah, perpetuity will do. Gunjan, perpetuity will do. Perpetuity is there. In fact, will do. Perpetuity is something, you know, when the annuity becomes infinite, we'll do that. Right. Okay. Sudesh, I think I have cleared your doubt. Yes. Fine. Example 4B, 13 years. Many of you have said I'll do it. So what to do with this? We have the birth rate and we have the death rate. So birth minus death means the growth in the population, right? So what we do is per 1,000, 39.4 people are born and 19.4 people are dying. So the difference, let's see, the difference is 39.4, which is the birth rate, minus 19.4, which is the death rate. So 39.4 minus 19.4 gives you 20. So we can say that the difference is 20% when we have per thousand population. Per thousand population, 20%. So on 100, so we are having how much? 20% we are assuming on 1,000. 20 people is the total increase in the population per 1,000. So in 100, what will be the rate? So if 20 is the rate for 1,000, so 20 is the rate for 1,000. So, or I'll put it in this way. For 1,000 population, the increase in the population is 20. Okay. So for 1, the population increase will be 20 by 1,000. And for 100, it will be 20 by 1,000 into 100, which is 2%. So I'm using the unitary method which you learned in school long back. For 1,000, 20%, for 1, 20 by 1,000, for 100, 20 by 1,000 multiplied by 100, which gives you 2%. That means the annual rate of increase in the population is 2%. Okay, so let us note it that it is 2%. So I'm writing the increase is basically 2% per 100. Now comes the question that it is like an annuity question. In fact, sorry, it's a compounding question. Now we have to find out in how many years the population will be doubled, right? So if we assume that, say for example, if we assume that the original population is 100, okay, the original population is 100, original. So it will become doubled. Doubled means 2 times. So the new population will be 200, right? So I can equate 200 is the new population, and it will be basically achieved over n number of years, where 100 is the original population into 1 plus growth rate. Here growth rate is 2%. That means 0.02. So 0.02 to the power n. N is the number of years which is required so that the population becomes double. So what do I get? 100 and 202. 1 plus 0.02 gives you 1.02. So I'm getting the equation 1.02 to the power n is equal to 2. So this is the worst part. If you get a log table, it is easy. Otherwise, you have to go on multiplying 1.02 into 1.02 into 1.02 till you get approximate 2. If you do it, it comes to n equal to 35. So the answer is 35 years it takes for the population to become double when the growth rate, the net growth rate is 2% for 100, for every 100 persons. In other words, it is 200, it's 20 for every 1,000, and we have got the 20 by subtracting the birth rate, which is given 39.4. Once again, please see the steps. 39.4 minus the death rate 19.4. So we have got 20%, which is the annual net growth rate, and this is equal to 20% for 1,000. So the increase is 2% for every 100 population, and 2% means 0.02. Okay, then we have used the formula original population 1 plus increase to the power n, which is the formula for the compounding. For compounding, that is original value into 1 plus interest to the power n gives you the compounded value. So using the formula, this is what we are getting, and if you solve for n, we are getting n equal to 35. Right. Now we will take the next problem from the exercises, and let's see what is there in the next problem. This is a very good question I have taken from the past exam, and this question is a question on simple interest and compound interest together. The question is, which one is a better investment? They are giving 2 investments. Which one is better? Okay, I'm writing A and I'm writing B. Investment A is 3.6% interest per year compounded monthly. So 3.6% interest per year, and the compounding is done monthly. Compounding is done monthly, right? Compounding is done monthly. The other alternative is 3.2% per year simple interest. Option B gives you 3.2% interest, and that is simple interest, SI. So which one is a better investment option? You have to find out. Friends, we try to solve these problems by using the effective rate of interest method, right? And that's why we learned about the effective rate of interest. Some of you were asking, what is the practical application? I discussed it. Now you can see you can yourself find out the answer. So when we have to compare between two different investments, we always use the effective rate of interest to compare the two rates, right? So here it is said that 3.6% is the interest which is paid per year, but the compounding is done monthly. That means 3.6% is the annual interest. So you need to find out the monthly interest. So let me work it out together, and request all of you also to put your brain together and put your efforts, and then let's work it out. Okay, coordination of brain and hand. Even though it's second session, you might feel a little bit tired, but then yes, you have to fight and clarify all your doubts and make sure that you get confident, right? And always remember that mathematics, right? Think of the movie. I'm sure you'll get motivated. Super 30. So athletes, we are mathletes. Mathematics and athlete, we become mathletes. Always remember that. Now, 3.6% is the annual interest. That is annual interest, 3.6%. So the monthly interest will be how much? 3.6 by 12, because there are 12 months in a year. So this gives me how much? Be careful when you, there is a decimal sign, so be very careful when you solve it out. So it gives me 0.3%. Okay, it gives me 0.3%, just checking, 0.3. Now 0.3% means 3.6 by 12 is 0.3. Okay, so I've divided 3.6% by 12, it is 0.3%. But 0.3% actually means how much? 0.003. So don't forget that step. This is equal to 0.003. 5% means what? 0.05. So two places of decimal. So 0.3, we will have two places of decimal. So 0.3 is here. So it will shift two places, 1 and 2. So you get 0.003. Now it is easy. So we can find the effective rate of interest. And you know the effective rate of interest formula is 1 plus I to the power n minus 1. I was just writing it a little while back when I was doing the recap of all the important formula, right? So let us just see what it gives us, 1 plus I to the power n minus 1. Now let me work it out and see. 1 plus I is this, 0.003, okay, 0.003. So therefore I write 1 plus 0.003 to the power n. Now n is how much? It is compounded monthly, and the interest is paid. You can see it is basically n is equal to 12, because we have to find the annual impact. So to the power 12 minus 1. 1 plus I to the power n minus 1. 1 plus 0.003, which is the interest rate, to the power 12, because n is 12 here, minus 1. So this again means calculation, and you have to go on calculating. So just try out and see what you get. So 1.0366, I think you'll be getting 1 plus 0.003. If you just 0.003 to the power 12, if you do, you'll be getting something like 1.0366, okay, minus 1. So you are getting 1.0366 minus 1 means how much is it? It is basically 0.0366. 1.0366 minus 1 gives you 0.0366. This in percentage terms means it is 3.66% on an annual basis. Right, and this is what you get on an annual basis. This is investment A. Investment B gives you 3.2%. So which one is better? Investment A on an annual basis is the effective rate of interest is 3.66, but investment B is giving 3.2. So which one will you choose? You will choose investment A. Okay. So the compounding impact, even after compounding, right, the interest will always increase. And since it's the case of monthly compounding over a period of 1 year, you can see that the interest rate is 3.66, whereas the interest rate in case of option B is 3.2, which means that the effective rate of interest formula and the process we have used, and we have got the result that investment A is better. This is very important question, and you can see that step by step how we have solved it out. We now move on to exercise 4C. I'm taking few questions from exercise 4C. I'm taking question number 12. Then let's see what is there in this question. Exercise 4C number 12. The question says, what is the present value of annuity of 5,000 rupees? 5,000 rupees annuity per annum, of course, 5,000 rupees per annum for 12 years. For 12 years, okay, at 4% compound interest. Okay, and compound interest is annual. It is annual. Okay, compounding is done annually. So, what will be the present value of this sum? What will be the present value of this sum? So first, let us find out what will be the actual amount. Okay, 5,000 rupees. 5,000 rupees. You are going on putting that money every year in an annuity, because you know annuity means fixed rate of payment every year. So 5,000 rupees going in first year, 5,000 rupees going in second year, and the interest earned is 4% compounded interest annually. So this is, it appears like an annuity regular. So if the question does not say anything, it is assumed to be annuity regular. Okay, so we assume the formula of annuity regular, and let us see what we get. So step number 1, let me write step 1. So annuity regular. Now you know the formula for annuity regular. This is equal to A into 1 plus I to the power n minus 1 by I. This is the formula. So let us put the values and see what we get, right? Okay. Yeah, let us do this first and then see the questions. So 1 plus I to the power n minus 1 by I. This is the formula. So let me put the values here and see. So this is equal to A is 5,000 every year into 1 plus I. I is 4%. 4% means 0.04. 0.04. I have no alternative but to multiply, because n is 12 years, so to go on multiplying. So I write to the power 12 minus 1 by I, and this I is 0.04. So it's pretty long calculation, but let us do it. Okay, if log table is given, might be easier, otherwise you have to calculate. So this means 5,000, let me simplify as much as possible. 5,000, okay, so this is divided by 0.04. Okay, 0.04 means 4 by 100. So I can say this is multiplying by 100 and divided by 4 and multiplied by this numerator. So 1.04, 1 plus 0.04 is 1.04 to the power 12 minus 1. So go on multiplying. Okay, 1.04 into 1.04. Okay, let's see what we get. 1.04 into 1.04. Okay, 10 times done. 11 and 12. Okay, 1.6010322. So I'm getting, this is 5,000 into 4, this is 25. So 5,000 into 25 into, what I'm getting here is 1.6010322 minus 1. Let me see if we have got it correctly or not. Okay, so 1.6010322 minus 1. So this gives me 5,000 into 25, that is 1,25,000 into 0.6010322. Let me just check the multiplication. Yes, this is 125,000 into 0.6010322. Just let me see. Okay. Now this is coming to 75,129. Let me just write it out. 75,129. Okay, 0.025. Okay. This is the future value. Now you have to find the present value. Okay, so what we do here is let's find the present value. And present value, you know, is nothing but future value divided by the what? The future value divided by 1 plus I to the power n. So in this way, we have got the future value. So 5,000 every year, if you go on putting it, right, after factoring the interest, the total amount will be 75,129 in 12 years. So now if you find out the present value, let me just write 75,129, it came, just a moment. So let me just check. 75,129. This is the future value. Okay, so we have to find the present value. So step 2 is present value is equal to future value divided by 1 plus I to the power n. So future value is 75,129 approximately, and 1 plus I to the power n, we do the same calculation which we have done earlier. 1 plus 0 points, the interest rate was 4%, so 0.04 to the power 12. If you do it, we are getting, because 1 plus I, we have just done this calculation earlier. So if you do it once again, we were getting something like 1.6010322. So if I do it, if I divide this by 1.06, yeah. So if I do it, I am getting, once again, 75,129, 75,129 divided by 1.60322 approximately, we are getting 46,925. So the present value is 46,925, right? Point something, more 0.3 or 4. So this is how we find out the present value of the annuity which is given. So annuity, you know, it's like a cash flow every year which goes on, and you have to first find out, after working on the annuity amount, you have to first find out what is the total corpus which will get developed. Every year the money is getting, annuity means, you know, fixed rate of payment in a at a fixed time interval. So in this way, you find out the future value, and from there, you just find out the present value by using the formula, present value equal to future value divided by 1 plus I to the power n. Now we take another interesting problem, and this is an exam question. Ram buys a scooter costing 73,000. Scooter. The cost is 73,000. Fine. Now, a down payment is made of 3,000. I was explaining last day what is down payment. Down payment is the immediate cash payment you make to buy whatever, a bike or a car or a laptop, whatever. So the down payment is 3,000. Okay. And he agreed to make equal annual payment for 4 years. So he said that I will make an annual payment for 4 years, it will be equal. So instead of equal monthly installment, EMI, he agreed to go for an equal annual installment, where I is interest and A is annual. And he said that I will pay the amount of the loan in 4 years. So N, or the time is 4 years. Fine. Now the question is, how much should be the amount of each payment if the interest is 14%? So the interest is 14% and this is compounded annually. This is compounded annually, compound interest annual. Okay, and it is given, you are given the annuity factor, and the factor is given P4 0.14. That means for 4 years at rate of 0.14, that is 14%. You are given the factor is 2.91371. So let us see what to do in this case. Let us just check what to do in this case and see. Now, let us see the question once again. So Ram is buying a scooter, okay? And he is buying the scooter. The total cost of the scooter is 73,000. He makes a down payment of 3,000, right? That means what is the loan amount? He is making a payment of 3,000. So what is the loan amount, right? The loan amount is how much? 73 minus 3, that is 70,000. He agrees to pay this 70,000 over 4 years, right? It is given that he has agreed to pay in 4 years. N is 4 years. And the interest rate is 14%. So we have to find out what will be the value for every year. Now, this is a very simple question, and since the entire calculation is given for you, ideally, what should have been the formula? The formula is that you remember the annuity formula, annuity regular formula. The formula was that the total annuity will be equal to the, sorry, let me write it this way, is equal to cash flow into 1 plus I to the power n minus 1 by I. Here, this is something we know, this is 70,000. This is 70,000. The cash flow we don't know. That means the cash flow per year, the amount he has to contribute per year, we don't know. But we know that this entire amount which you see here is given, and this amount is 2.9137. So cash flow into 2.91371. So it's simple for you now. The problem has been made very simple for you. You have the amount, you have the cash flow which you are about to find out, and the factor is given. The annuity factor is given. So therefore, the cash flow will be equal to 70,000 divided by 2.91371. 70,000 divided by 2.91371. Let me just work it out and see. Just see what we are getting. 70,000 70000 divided by 2.91371. I'm getting 24,024. So I'm getting 24024.35. And I guess this is the right answer. So in this way, in this problem, we have seen the scooter cost is 73,000. The down payment is made 3,000, which means the loan is 70,000. So I'm taking a loan of 70,000. I want to repay it over 4 years' time, and the interest rate is given at 14%, right? So we have to just see. We have just got to see the annuity formula is used, and just if you use the annuity formula, what we get is, by applying this formula, cash flow into 1 plus I to the power n minus 1 by I, right? What we see is that this entire factor, annuity factor, is given. Otherwise, we would have, we had to calculate that. But the entire work has become simplified because this annuity factor is given, 2.91371. So I just multiply the cash flow into 2.91371, and this should be equal to the given amount, which is 70,000, and just a simple calculation, and we have got the answer. The answer is, as you see, 24,024 shall be the yearly contribution which is to be made by Ram so that he can buy the scooter and he can pay off the loan in 4 years' time. Okay, so this is solution to this problem. Now we are taking exercise 4B, question number 14. Let me take the next question and then we will go into the applications quickly. So we take exercise 4B, number 14. Right, let's take exercise 4B, number 14. Yeah, this we have done already, 243.6, we did this. Okay, yeah, this is a nice one, exercise 4C, number 13. Okay, exercise 4C, number 13, please see. A person wants to create a fund which is to be invested at 10% compound interest to provide for a price of rupees 300 per year. Okay, so I need a fund which shall be invested at 10% compound interest so that every year I can generate 300 rupees for the purpose of giving a price. And in the problem, it is given that V is equal to A by I, where you can understand that A will be basically, A in this case is what? A is nothing but the every year the prize money which I require, and I is the interest rate. So they have given that use the formula V equal to A by I, where V is the amount of this original contribution, right? The original contribution which should be kept, right? V, and this is equal to A by I. Now A is how much? A is given, A is 300, because I need to generate 300 rupees per year. Okay, I need to generate 300 rupees per year so that I get a prize. So what is this 300 rupees? This is the annual prize money which I require, and this is A. So I put 300 here, and the interest rate is 10%, which is how much? 0.1. 10% means 0.1. So I put 0.1 here. So I get 300 divided by 0.1, which is 3,000. So the actual amount to create the fund should be, the fund amount should be 3,000. Just check. Just check the process and see if you are able to understand. Okay, so it's a very simple question, and they have given directly that you can use this formula, which is V is equal to A by I. Okay, so just see this formula. Right. Now we'll take the next question, and this is going to be a simple interest question. Just quickly, let us take it up. The more number of questions we do, the better it is, and you have better clarity. This question is from the special questions which are prepared by the Board of Studies. Now the question is like this: Vidya deposited 60,000. So let me take the question. Vidya deposited 60,000 rupees. Vidya deposits 60,000 rupees in a bank for 2 years at the rate of 5.5% simple interest per annum. Okay. How much interest will she earn, and what will be the final value of the investment? So what will be the interest part? We don't know. And what is the final value of the investment? What will be the final value? We don't know. Okay, so let us try and do this question and see. Now, the question is like this. You know that the principal is 60,000. Okay, and this is kept for 2 years. So the duration is 2 years, and the interest rate is 5.5%. It is given that the interest rate is 5.5%. How much interest she will earn, and what will be the final value of investment? This is something which you need to find out. So this is a question on simple interest. So you know that in case of simple interest, the interest amount is equal to principal into interest rate into the time. Okay. So you have P into I into T. Okay, just check this, P into I into T. So let me do the calculation. This will be equal to principal is 60,000 into interest. Interest is how much? 5.5%. Now 5.5%, just check what is 5.5% equal to. So if you see, what is 5.5% equal to? Now 5.5% means it is 0.055. Okay, 5.5% means 0.055. So 60,000 into 0.055 into time. Time is how much? 2 years. I think it is given 2 years. So I multiply by 2. P into I into T. So this gives me, let me multiply and see. Let me come to the calculator and check and see. This is 60,000 multiplied by 0.055 into 2. I'm getting 6,600. Please check. 6,600. Okay. 6,600. Just check. So we get 6,600 here, and this is the interest amount. And if this is the interest amount, you can find out what will be the total amount. Amount is equal to principal plus interest. Here, principal is 60,000. I write 60,000 plus the interest is 6,600. 6,600. So the amount is 66,600. Okay, 66,600 is the total amount. I think this is clear, and you have been able to understand. It's a question based on simple interest and pretty easy one. Right. We will take one more question, which is from the past years. And it will be good if you get these easy questions in the exam. Definitely all of you will score good marks and get the answers correct. So let us check this particular problem now and see if we can solve it. And the question is that Rajiv invested 75,000. Rajiv invested 75,000 in a bank at the rate of 8% per annum. So please note the problem. 75,000 is invested in a bank at the rate of 8% per annum. So 75,000 invested at the rate of 8% per annum. Simple interest. It is given. It is simple interest. Very good. So 75,000 invested at 8% per annum simple interest. Now he receives, of course, the money is invested for a certain time. Now he receives 1,35,000 after the end of the term. He receives 1,35,000 at the end of the term. For how many years it was invested? Okay, so here we use the simple question, the simple equation, and that is A is equal to principal plus interest, where principal here is 75,000 plus interest is nothing but principal into interest rate into time. So I will write 75,000 into interest rate. Interest rate is 8%. So this is 0.08. 0.08. So I will write 0.08 into time. Time we don't know. And this right hand side which you see here, the right hand side which you see here is equal to the amount, because he received the amount of 1,35,000. So 1,35,000 is the amount. Now just try to solve for this equation and see what happens. So let me multiply the this side and see what we get. 75,000 into 0.08. So let us see what value we are getting. 75,000 into 0.08. This comes to this. I'm getting 6,000. So let me just put it in this way. So 1,35,000. So I can write like this. This is 6,000. So I can write 6,000 into T. 6,000 into T. 6,000 into T. This is equal to 75,000 into 0.08 is 6,000 into T. This is equal to 1,35,000 minus 75,000. So how much is that? 1,35,000 minus 75,000. So this is equal to 60,000. Okay, so you can see 6,000 T is 60,000. So T is equal to 60,000 by 6,000, which is equal to 10. So the time period is equal to 10 years, and this is the solution to this problem, right? We have done the compound interest. Yes, now we go to exercise 4D quickly, and we will see some questions from there and also few questions from the additional question bank, right? So exercise 4D number 2, I'm trying to do exercise 4D, number 2. Just try to see the problem, exercise 4D number 2. Okay. Exercise 4D number 2, the problem is like this. 4D number 2, principal is given 1,000 rupees. Principal is given, N equal to 4 years, the time is 4 years, and the rate of interest is 5%. So I is equal to 5%, which means 0.05 straight away. What is the compound interest? So the compound interest is how much? What is the CI? Okay, what is the CI? So compound interest is equal to, the compound interest part is equal to total amount minus principal. The amount is how much? Principal into 1 plus I to the power n, and this minus p will come here. So p, if I take common, it will be 1 plus I to the power n minus 1. This is the formula for compound interest, to get only the interest part. Okay, if you want to find the total amount, that means after compounding, what is the final amount? Then the formula is this much. Okay. So let us try and put the values in the given problem and see what happens. So this is equal to P. P is how much? 1,000. So let me put 1,000 here. 1 plus I. 1 plus I is 0.05. 0.05 to the power 4 minus 1. So I have 1,000 into 1 plus 0.05, that means 1.05. So 1.05 to the power 4 minus 1. So I have to multiply 1.05 4 times. Let me try it out and see. 1.05 into 1.05 into 1.05 into 1.05. So 1.2155 minus 1. This gives me 0.2155. So this is 1,000 into 0.2155. So I'm getting 215.50. So I'm getting the compound interest is rupees 215.50. Okay, so I'm sure it's clear, and you can see this is from exercise 4D. So compound interest is the amount minus principal. This amount is principal into 1 plus I to the power n. We deduct P here minus P. So if you take P common from the whole, you get P into 1 plus I to the power n minus 1, and you put the values to get the answer 215.50. We push on to the next question, exercise 4D, and we take number 3 now, question number 3. So let me take question number 3. The same exercise 4D, we just go to the next problem, number 3, and see what is there in store for us. So I'm taking number 3. What is the time in which a sum of money will double itself at 5%? Compound interest is annual. So what is the time in which a given sum of money doubles itself? That means it becomes double. Okay, when the interest rate is 5%. Interest rate is 5% compound interest, right? So you remember, friends, that we discussed about the rule of 72, 114, and 144. I hope you remember that. So it's a very simple calculation, right? A one-step solution. So we apply the rule of 72. Of course, it does not give you 100% accurate answer, but it gives definitely an answer which is you arrive at the answer in a much shorter span of time, and it's fairly accurate, right? So what we do is rule of 72, if you apply, so the number of years will be 72 divided by 5. I told you that the rule of 72 means the number of years in which an investment doubles itself at a particular rate of interest, which is on compound interest basis. So if the rate of interest is 8%, the money will double itself in 72 divided by 8. That is 9 years. So here it is 72 by 5. Quickly, let me calculate. It gives me 14.4 years approximately. Okay, this is number 3. So we have done this. Now we go to number 5. The same exercise, we are doing number 5. I am completing as many problems as possible from the study material, also from the past exam questions, and also from the MTP. So we take number 5. So question number 5. The question is again very simple. In how many years a given sum of money will triple itself? It will triple itself. So 3 times. When the interest is 8% per annum, of course, compounded. 8% per annum, compound interest. So I will apply which rule? Which rule to be applied? Triple itself. So I will apply the rule of 114. Apply the rule of 114. So the time T is equal to 114 divided by 8, because 8%. So it gives me 14.25. 14.25 years. So accordingly, you can just check which option is correct. I think in the options given, option number A will be correct. Okay. Now we move on and we take some questions from the additional question bank. Okay, I'll take the AQB now, additional question bank, and then we will move into the application. So AQB, the additional question bank, I'm taking number 1. Okay, we have to find out the difference of compound interest minus simple interest for 20,000 rupees, okay, for 4 years at 5% interest. So 20,000 rupees, 4 years, that means 2 options are given, 2 investments. One is 20,000, 4 years time, and the interest rate is 5% per annum simple interest. And the other option is same amount, 20,000 invested for 4 years, but this time the interest is not on simple interest, it is 5% compound interest. So what is the difference between the 2 total interest? Now we saw some shortcuts. For 2 years, yes, pi square. For 3 years, it is 3 pi square plus pi cube. But for 4 years, it's better to work it out. So let me work out the simple interest for 4 years. Simple interest for 4 years is very simple. 20,000 rupees per year, it is 5%. So per year, I'm getting 5 by 100 into 20,000. This is my interest for 1 year. So for 4 years, it will be multiplied by 4. So how much is this? 100 and 100 goes out. 200 into 5 is 1,000. 1,000 into 4 is 4,000. So I get 4,000. Fine. No problem. Clear. Now the compound interest. So we know the compound interest formula is very simple. P principal into 1 plus I to the power n minus 1. Right? So let me put it. P is 20,000. 1 plus I is 5%. So I will write 0.05 to the power n. N is 4 years, so to the power 4 minus 1. Again, let me work it out quickly. It comes to 1.20,000 into 1.2155. This amount comes to 1.2155 minus 1. So if you simplify it, the difference is coming to 310. So answer is that the difference in the 2 interests, that is the interest on 20,000 for 4 years at 5% compound interest minus the interest on 20,000 rupees for 4 years at simple interest, the difference comes to 310 rupees. Okay, I hope it's clear. Yeah, we will now take AQB number 7. And then we will go to the applications. Okay, AQB number 7, the question number 7, additional question bank. AQB number 7, and let's see what question is there for us to solve. I hope with more and more problems we are solving together. Definitely, see, there are hundreds of problems. We cannot take all the problems here. Then as you saw that we have 2 hours. Every day we cross beyond 2 hours, but then there's a limit up to which we can do. So definitely all problems cannot be solved, but most of the important problems we are solving, given the time and given, of course, the fact that every day we have a tight schedule. Every day we have to complete one particular chapter, or we have to complete a part of the chapter, right? So let us take AQB number 7. In how many years sum of money will triple itself at 5% interest, compound interest, with a half yearly compounding? So here also we apply the rule of the interest is 5% given. So we apply the rule of 114, and it becomes 114 by 5, which we get as 22.8 approximately. So 22.8 years, the amount of money will triple itself. Now we go to the applications, and the first application we see is very important. This is on leasing. Now, many of you you have heard about the term lease. Okay, so we will go into the applications and see. Okay. Fine. Let me take some of the lot of points are coming. Yeah, Amit is writing every decimal multiplication is necessary. Yes, in most of the cases, decimal multiplication is necessary. Okay, Suprada, you have said that you have now got the answer correct. Fine, thank you. Very good. Good that you followed the session and you were able to rectify your answer. Okay, Shweta is asking a question. She's from Chennai. Is security deposit and down payment? No, security deposit and down payment is not the same. Now, security deposit, say you want to become a member of a library, right? Now, if I take a book from the library and if I lose the book or if the book gets damaged, I have to pay an amount. So what the library does, they tell you that, okay, you become a member of the library and you pay a security deposit of, say, 1,000 rupees. When you decide not to continue as a member of the library, we will refund that 1,000 rupees to you, provided you have not damaged any of the books. If you have damaged a book, okay, then and the cost of rectifying the damage is 400 rupees, then we will not entirely pay you that 1,000 rupees of security deposit. We will pay you 1,000 minus 400, 600 rupees will be refunded. That is security deposit, Shweta. And down payment means the initial payment. You just Google out down payment. You see any advertisement in the newspaper which comes in your area. So you will find a scooter, down payment is so much. You want to buy a smart TV, cost is 40,000, down payment is 5,000, remaining is on loan. Okay, down payment means the initial cash payment which you have to make, right? Okay. Siddharth Mudaliar from Pune, which type of loan has the highest rate of interest charge? I was discussing last day, Siddharth, personal loan, higher education loan, it will always have the highest rate of interest. Say you want to go for, you want to become, you want to do an MBA from US, you want to become a pilot, right? Now, if you want to become a pilot, it will take you almost 60 to 70 lakhs. Now, question is, or if you want to go for an MBA from a foreign institute, it can be 40, 50 lakhs. Right. So people go for education loan. So when the bank gives you an education loan, now it's very risky because after taking the loan, what is the guarantee that you will pass the exam? What is the guarantee that you will get a job? And unless you get a job, how can you refund the loan? How can you repay the loan? So there is a risk. Therefore, personal loans, education loans, they attract one of the highest risk. Similarly, if a startup company applies for a loan, right, then it will attract more interest because the risk is more, right? Good. Yes. Good. A lot of points are coming. Fine. Okay. Okay. Bhavika is asking when to apply which rule. Well, Bhavika, you will get the question. Read the question carefully. It will be written either 2 times or 3 times. If it is 2 times, you apply the rule of 72. If it is 3 times, apply the rule of 114. If it is written that 4 times, say it's given that 16% is the interest rate, compounded interest rate. In how many years, say it will become 4 times? So it is 144, rule of 144. 144 by 16, you will get 9 years. Right. Okay, Muskan, the rule of 72, 114 and 144 is applicable for compound interest. Okay. Okay, fine. Yes, Tanu, it is down payment is the initial payment you make. Okay. Yes, Jyoti, you have to remember 5 or 6 formulas. You cannot, there's no shortcut to it. Right. Okay. Tanu, if I have to invest in shares, which company shares should I take? Well, you have to take shares of companies which have the highest credit rating and which has a very good track record with good management and performance. Okay. Now we will carry on and see what type of applications. So we first take up leasing, right? So we will talk about leasing, which is the first application. Now, what happens in leasing is renting. Lease is nothing but a rent. So instead of buying a particular machine, you can take the machine on rent. Now, the question is that if you take a machine on rent, then what happens? You don't have to pay the initial down payment. You just pay the monthly rent or the annual rent, and you can use the machine, right? So this is very similar to taking land. You see, you hear about leased land. Land is taken on rent for 99 years, maybe for a longer period of time. Building is given on rent, office space is given on rent, and we use the word lease. Okay, so lease. In accounting standards also, you will read accounting standard 19, which is on lease. You can check it. Accounting standard 19 is on lease. And under the new Indian accounting standards, which is there, Indian accounting standard 116 also covers lease accounting. Right. So lease is nothing but a rent. Now let us see page 4.34, example number 36. 4.34, example number 36. Example, okay, let me go to 4.34 and just we will see the page 4.34. Let us see the example. A company wants to lease out an asset costing 3,60,000 for a 5-year period. That means it wants to lease out an asset which is costing 3,60,000 for 5 years. Fine. The rent per annum is 1,05,000. So the annual rent, that means the annual lease, the annual rent is 1,05,000. 1,05,000. So if it is 1,05,000, then, and it is clearly given in the problem that the payment is made annually. The payment is to be paid annually starting from the end of the first year. So it is nothing but an annuity regular because it's at the end of the first year. Suppose the rate of interest is 14% compounded annually. So it is an annuity regular, I'm writing, and the interest is 14% compounded annually. Fine. So whether the agreement is favorable to the company. Now, the company is going to get 1,05,000 for 5 years. I think it is given for 5 years and at the interest rate of 14% per annum, compounded annually. So let us find out what will be. Of course, in the problem it is given, the value of the annuity factor is given. The annuity factor is, if you see, P5, that is for 5 years at 14%. The factor is given 3.43308. Okay. So that simplifies our calculations. So the present value of the annuity, basically, now you are going on paying 1,05,000 every year for 5 years, and it is getting accumulated with a compound interest of 14%. Okay, so definitely it will lead you to a certain amount of money. Okay, 1,05,000, again 1,05,000, and the money is reinvested. I mean, you are getting an interest. The question is, you will get a amount of money which you will get after 5 years. Now, what is the present value of that amount? That means 5 years later, if the amount is so much, what is the equivalent amount today? That is the present value. So the present value, if you just apply this present value factor which is given, so it will be equal to the cash flow which you are getting, 1,05,000 into this factor. So it is 3.43308. If you calculate, this comes to 3,60,473.40. So what happens? What is your conclusion? So that means if the company sells the asset, right? If the company sells the asset, he will get 3,60,000. But if you lease the asset in 5 years, the present value is coming to 3,60,473. This amount is more than the cash payment. So therefore, leasing is better. So in this case, leasing is to be followed. The company should lease out because they earn higher return. Of course, here the difference is only 473 rupees because 3,64,73, and here you have 3,60,000. But overall, leasing is beneficial simply because you are getting higher returns when you lease out the machine, right? So this is the concept of leasing versus outright sale. Okay, we will take one more question and on one more example, which is there in the, I think, the study material, and we will see the question. Okay. Right. A company is considering a proposal to purchase a machine. So let me write the facts of the question, and then we will apply the formula and, of course, the logic, the relevant logic to be used. A company is considering proposal to purchase a machine either by making a full payment of 4,000. So either you have to make a cash payment. I'm writing cash payment of 4,000. You pay 4,000 and take the machine away. No questions asked. So this is option number 1. Option 1. Option 2. You pay a lease rental of 1,250 rupees per year for 4 years. Okay, for 4 years. And the interest rate is 14%. The interest rate is 14%. And it is compounded annually. So compounding is done annually. Which one should be done? So you see, many people buy different commodities on lease or on sometimes on loan, right? So here again, you see the idea is that either you pay 1,250 rupees per year for the next 4 years, but it will have a 14% interest. Otherwise, you make a direct payment of 4,000 and buy the asset. So which one is better? So here again, we will see what is the present value of all these payments which is being made. That means to calculate the present value, you see 1,250 I am paying after 1 year. Okay, year 1. So the present value of 1,250 which I am paying after 1 year will be value divided by 1 plus I to the power n. So 1,250 by 1 plus I is 14%, 0.14 to the power 1. Again, after 2 years, 1,250 divided by 1 plus 0.14 to the power square. So in this way, it will go on. For how many years? For 4 years. So the third year will be 1,250, 1 plus 0.14 to the power 3. And in the fourth year, again, 1,250 divided by 1 plus 0.14 to the power 4. So this will give you the present value. So if I take 1,250 common, what do I get? 1 by 1 plus 0.14 plus 1 by 1 plus 0.14 square plus 1 by 1 plus 0.14 to the power cube. Just see how it is increasing. Plus 1 by 1 plus 0.14 to the power 4. This full factor which you see, okay, this full factor is given. Otherwise, we would have taken more time to solve it. So this full factor is given, and this full factor is equal to 2.91371. This full factor is equal to 2.91371. So we can directly find the present value. We know the cash payment per year. So the present value is 1,250 multiplied by the present value factor which is given, that is 2.91371. If I multiply it, I am getting 3642.11. 3642.11. Now, that means what? That means if I buy, I have to pay 4,000, and if I take it on lease, I have to ultimately make a payment of 3642.11, 3,600. Which one is better? Which one is lesser? So I think leasing is lesser. If you have to make a cash payment, the total impact on your pocket is 4,000. If you lease it out, if you buy it on lease, that means if you buy it on loan, and you pay an equal annual payment of 1250 per year, then you are ultimately paying 3642. So that means in this case, leasing option 2 is preferable. Okay, so this is how we solve these problems, and this is how we get the entire solution done. Okay, Shreya is asking how to calculate annuity factor. Annuity factor will be given. Basically, annuity factor is what? In case of annuity, cash flow into 1 plus I to the power n minus 1 by I. This is the annuity factor. This part is the annuity factor. This is given. In many of the problems, it is given. Otherwise, you have to calculate. No other way. Right. Yeah, Pooja has said leasing is better. Yes. Fine. Yeah, Kushi is asking, do we get the tables that we have behind the book? Yes, the log tables and the other tables is, I think in most of the exams it is allowed, it is given. Okay. Okay, now we move on and see the question on bond capital expenditure. And we will take the question on the next application is capital expenditure, and we will see how it is taken. Now, capital expenditure means very simple. You are expanding your business and you are buying a new machine, and the question is whether the machine is to be purchased or not. Now, why do you buy a machine? Because it gives you return. Okay, you get some output from a machine. Machine is an asset. Asset gives you cash inflows, right? So the cash inflows which you get from the machine over a period of time, the present value of the total cash inflows which you earn from a machine should be at least equal to the cost of the machine. Otherwise, there is no point buying the machine. So if the cost of the machine, say the cost of the machine is 1 lakh, and the present value of the benefit which I get from the machine is 95,000, should I buy the machine? Should I buy this machine? Yes or no? Let me see. The cost of the machine is 1 lakh, and if cost of the machine is 1 lakh, if the benefit I'm getting is 95,000, right? Should I buy the machine? Absolutely no, because my cost is more than my benefit, right? Okay. Okay. Yeah, Sudesh, I explained your doubt. You are writing so many times. Sudesh, I explained your doubt in the beginning only regarding PPF. PPF is Public Provident Fund. It is not at all pension scheme. Somebody gave you the wrong information. If you are in doubt, just Google out PPF. You will get the details. Okay. Right. Yes. So now we take up this question. So cost is 1 lakh and the present value of the benefit is 95,000. There's no point buying the machine. If I make a different factor, different values, say the cost of a machine is 4 lakhs and you get a benefit of 4,95,000 by using the machine. Should you buy the machine? Yes, because the benefit, the present value of the benefit is more than the cost. So this is how capital expenditure, we are talking about capital expenditure. In brief, it is called CAPEX, capital expenditure, CAP and X, CAPEX. Now, let us see the problem and you will quickly, you'll be able to grasp the application. The application part is very easy because it is just based on the formula we have done, and it's just using your logical sense, your common sense. Now, if you see the example from the study material, machine is purchased for 50,000. So the cost of the machine is 50,000. Fine. I'm noting the cost 50,000. Machine will contribute how much? 12,000, it will contribute 12,000 for 5 years. So year number 1, 2, 3, 4, 5. First year, it will give you a benefit of 12,000. Second year, again 12,000. Third year, 12,000. 4 year, 12,000. And 5 years, 12,000. Fine. The interest rate or the borrowing cost is 10%, compounded annually. So the interest is 10%. That means 0.1. And this is compounded annually. Please note that. Okay. Whether the machine should be purchased or not. Very simple. So I'm getting the money, but not together. I'm getting 12,000 in the first year, 12,000 in the second year, again third, fourth, fifth. So I have to find the present value. Now present value, PV, first year, at the end of first year, if I get 12,000 by using the machine, what is the present value? The present value will be 12,000 divided by 1 plus I, and I is 10%, so it is 0.1. So I will get a figure. Second year, I am getting 12,000, but at the end of 2 years, at the end of second year. So the present value will be 12,000 divided by 1 plus 0.1 square. In this way, it will increase. Third year will be 1 plus 0.1 to the power 3. So this is how we calculate the present value column. Now, in this problem, if you see the present value factor is given, PVF is given, and the PVF is equal to 3.79079. The present value factor is given. So it simplifies our calculation. So 12,000 is the benefit I'm getting per year. And if I know the present value factor, then the total present value of all the benefits which I'm getting is 12,000 into this 3.79079. If you just calculate it, you will be getting 45,489.48. 45,489.48, which means that the cost is 50,000, right? But if the benefit, the cost of the machine is 50,000, but the present value of the benefit is 45,489. Should you buy the machine? The answer is no, because the benefit which you get by using the machine is less than the cost of the machine. So the cost is more. Therefore, it should not be purchased. That means capital expenditure should not be done. Right? So this is how we solve these problems. And yes. Good. So many of you have written no, not to be bought. Fine. Good. Okay. Now we go to valuation of bond. This is very interesting, but you will see there is nothing, no rocket science. It is just application of the same principle. So we go to the valuation of bond and we see what is bond, and we also understand what is the method of bond valuation. So we are writing bond valuation. So what is a bond? You know, bond is a security. So it's like a fixed deposit, you can say. So a company floats a bond, like recently Coal India Limited, then you have Power Finance Corporation. Many companies have floated their bond. Bond is like a debenture. So it's a debt security, which means that it has a tenure. Say you buy the bond at 100 rupees face value, you pay 100 rupees for one bond. If you want to buy 10 bonds, you pay 1,000 rupees, you get 10 bonds. The interest rate can be 6.5%, is normally moving between 6% to 7%. The last 1 year bond yield has come down. So it can be, say, 6.5%. So you get a fixed rate of interest for a fixed period of time. The bond is issued for 3 years, can be 4 years, 5 years, 8 years, whatever. After the 8th year is over, you get back your principal amount. That means I'm investing 1,000 rupees today. Every year I'm getting interest at rate of 6.5% on the face value. And at the end of the tenure of the bond, I get back my initial 1,000 rupees. Right? So now if you see the example, one of the examples from the study material, the question is like this. An investor wants to purchase a 3-year, So the bond has a life of 3 years. He wants to purchase a 3-year bond, and the value of the bond is 1,000 rupees. The face value, you know the face value of the shares. Same is face value of the bond, and this is 1,000 rupees, 1,000 rupees. Interest rate is 10%. So please note, this is not compound interest. Simple. Once again, I'm repeating, bond will always pay you simple interest. If they pay compound interest, they will lose their business. Okay. So the interest rate is 10% SI, that is simple interest. Now, if the investor requires a rate of return of 14%, so investor wants a return of 14%, right? Then what is the maximum price he should pay for the bond? So at what price the bond should be purchased, so that if it matures at par, that means, as I said, at the end of how many years? 3 years. If 1,000 rupees is refunded back, right, then what is the price at which the bond should be bought? So let us see the calculation. It's very interesting, but not at all difficult. You will understand. So what is happening is, I'm paying a certain price for the bond, which I have to pay now, right? Now, the face value is 1,000 rupees, face value, but I may not pay face value. I may pay more, I may pay less. The question is, what is the return I'm getting over the life of 3 years? So year 1, year 2, year 3. What is the interest I'm getting? The face value is 1,000 rupees and the interest rate is 10%. So 1,000 into 10%, I am getting 100 rupees as the interest. Interest is always calculated on the face value. Once again, I'm repeating, interest calculation for all financial instruments is calculated on the face value or the par value. Sometimes you use the word par. Shares are issued at par. Okay, shares are issued with a face value of 10, face value of 100. So here the bonds, the face value is 1,000 rupees, and therefore the interest is 1,000 into 10%, which is 100. So what am I getting as a bondholder? At the end of first year, I am getting interest rate of 100, interest of 100 rupees. But this is at the end of 1 year. So what is the present value of that money? The present value, I am creating the table. The present value is how much? 100 divided by 1 plus I. I is 10%, so 0.1. Second year, at the end of second year, I am also getting how much? 100 rupees interest. So 100 rupees. But getting 100 rupees after 2 years, what is the present value today? So it is 100 divided by 1 plus 0.1 to the power 2, raised to the power 2 square. Now, third year, I will get two things. I will get interest as well as the original amount which I had invested, 1,000 rupees, this will be refunded back to me. In other words, I will be getting 1,000, the original investment, plus the interest for the third year, which is 100 rupees. So 1,000 plus 100, 1,100. Third year, I will get 1,100, and the present value of this 1,100 is 1,100 by 1 plus I is 0.1 to the power 3. We have to calculate each of them. So 100, let us put our calculators ready, back into action. 100 divided by 1 plus 0.1, that is 100 divided by 1.1. Just let us see. 100 divided by 1.1. 90.90. Okay, so, okay, just a sec. No, there is one point to be incorporated. Yes, interest I'm getting 100. Yeah, the investor, this point, investor has expectation of 14%. So here interest rate which the investor expects is 14%. So here it will be 0.14. So this will be 0.14 square against 0.14 cube, because the investor expects 14%. Investor is looking at a return of 14%. So here the discounting factor will be 14. So let us calculate the first year present value will be how much? 100 divided by 1 plus 0.14, that is 100 divided by 1.14. This is 87.72. So I'm writing 87.72. This is the present value of rupees 100, which you will get after 1 year, where the interest rate is 14%, because we have the investors' interest is 14. Second year, let us calculate this particular term, 100 divided by 1 plus 0.14 square. So let us calculate it and see. 1.14. So 1.14 into 1.14, that gives me 1.2996. 100 divided by this. 100 divided by 1.2996. I am getting 76.947. 76.94. Okay, I'll take 2 decimals, 2 places after decimal. The third year I'm getting 1100 divided by 1 plus 0.14 cube. So let me calculate this. 1100 divided by 1.14 to the power cube, because 1 plus 0.14 is 1.14. So 1.14 into 1.14 into 1.14, I'm getting 1.4815. So it is 1100 divided by 1.4815. Let me calculate this. 1100 divided by 1.4815. This gives me, I'm getting 742.49. This 742.49, let me write it here, 742.49, and we have done the problem. I just add up these 3, this plus this plus this. So the total present value, which we are getting, which the investor is getting. So he is getting 100 rupees after the end of 1 year. His expectation is 14% return. So the present value of 100 rupees after 1 year at 14% present value, 14% interest is 87.72. So let us just add these figures. 87.72 plus 76.94, 76.94 plus 742.49, 742.49. I am getting 907.12. So approximately 907.1213, whatever. So this is the maximum price of the bond which you can pay. And even though the face value is 1000, but the maximum value you can pay is 907. If you pay more than that, then you lose out. Okay. So the purchase value of the bond should be 907.12513. This is how you solve, right? Yeah, face value means in shares and bonds, the face value is written 1000 rupees. It's a nominal value, but the share may be sold, or the debenture may be sold, or the bond may be sold at a higher price. It may be sold at a lower price than the face value. Here you can see that the bond has a face value of 1000 rupees, but the actual price which you should pay is 907 point something. So it means that you may not. Here you are paying an amount lesser than the face value, right? So this is how. Acha, Pooja is asking, please explain third year why you consider 1100. Pooja, please understand the bond. What is the rule of the bond? I put 1000 rupees to buy the bond. Okay, whatever I buy, I pay it today. First year I get back interest. Second year I get back interest. Third year I get back the interest plus. Here it is 3 years, so I'm taking third year. In the third year, I also get back my principal amount, right? So therefore, since the face value is considered as 1000, right, we are assuming that I will get back 1000 rupees plus 100, which is the interest, right? So once you assume that, you are getting the present value. That means this is the return which I should be getting. But at 14%, if I assume, then I am getting total benefit of 907.13 total return which I'm getting, starting with the interest in first year, interest in second year, interest in third year, plus repayment of principal amount. My principal amount is 1000. So if I think in these terms, the benefit I'm getting is 907. So if I pay 1,000 rupees to buy the bond, it will be a mistake. So the maximum amount I can pay is 907. Okay. Yeah, 3 years. Yeah, Venny, you can see 3 years means 3 years is because we have taken the bond tenure is given as 3 years. If it is 5 years, then first year interest, second year interest, third year interest, fourth year interest, fifth year interest and principal. Bond or debenture means at the end of the tenure, the principal amount which you are investing or the face value will be refunded. Here it is given in the problem that if you see the problem once again, here it is given that the bond is redeemed. The bond is redeemed at par. That means the redemption amount is 1,000 rupees. Where is 1,000 gone? 1,000 rupees. It is given. If it is given, say it is given in this problem that the bond is redeemed, that means repaid at a premium of 200. Try to understand. Then what I will do for the third year, if it is given that the bond is repaid at a premium of 200, that means in the third year, I will get the interest of 100 rupees, no doubt, but the amount which I will get back as my redemption amount, as my refund, will be a premium of 200. That means face value plus 200. Face value is 1,000. So 1,000 plus 200. So I will get 1,200 plus the interest 100. That is, I will get 1,300. Right? I hope it is clear and you have understood. So the problem clearly mentions that it is the redemption is done at face value. That means 1,000 rupees will be paid back to you. Okay. If it is mentioned that in the third year, the redemption will be done at a discount of 50. That means I will get 100 rupees, no doubt. But the amount, instead of 1,200, it will be 50 rupees less, 50 rupees discount. That means 1,000 rupees minus 50. That means I will get 950. 950 plus 100. That is what I will get. Right? I hope the process is now clear and you have understood why it is we are able to get, we are able to get the par value return. Now, definitely, if you shares and debentures you have not yet done. Yeah, in accounts, of course, it's there at the end. Shares and debentures. Yes, Sudesh, it's at the end. Okay. Okay, Moksha is saying that there are two different rates of interest in the problem. See, the company is paying an interest of 10%. But the investor may not agree to 10%. The investor has a higher rate of return. The investor expects more return, expecting 14% return. So if you expect 14% return, what will happen? The present value will become less because the denominator is going up. So the present value is becoming less. So the more your expectation is, you can understand the less will be the present value. Okay, that means higher the expectation of the investor, less he will be ready to pay. And unless he is ready to pay less, how can he earn the return? My expectation is huge, 14%. Market rate is 10%. So unless I pay less amount than the face value, how will I get the return? That is why instead of 1,000 rupees face value, he is ready to pay 907 rupees because his expectation rate is 14% and not 10%. Right? So please go through this again and then you will understand. Thank you. Okay, Venny has understood. Thank you. Good. Okay. Now we go to perpetuity, which is the easiest part, and just a small simple formula, which is basically high school level formula. Very easy, and then we will see the CAGR and end. So perpetuity means annuity which goes on forever. Okay, any annuity which goes on forever, no end, like going concern, company goes on and on, right? So the present value of the annuity. So say for example, every year you are getting 100 rupees as interest from a lifetime bond, which goes on paying you 100, 100, 100. So the present value of that bond is a calculation. Present value will be very simple. It will be equal to the payment which you get in every period. So I'm writing payment which you get in every period divided by what? Divided by the interest rate. Okay, so interest rate. right? You saw the simple example where 300 rupees is the price which you get every year and the interest rate is 10%. So what is the present value of the entire, the entire investment, right? It will be, that means you have to invest 3,000 rupees because 300 is the payment which you get per year and the interest rate is 10%. So basically you have to invest 3,000 rupees. If you invest 3,000 rupees, that will give you 10%. At 10%, you will get 300 every year, right? So this is perpetuity. Perpetuity means an annuity where the payments continue, or the receipt. Annuity can be cash outflow, which means a payment. It can be a cash inflow, which means it's a receipt. The question is, if it is indefinite, no limit, it goes on and on, okay, then it is called an annuity which is indefinite. This is called perpetuity. Perpetuity. You know the word perpetual means lifelong and forever. Perpetual. So the word perpetuity means an annuity which goes on indefinitely. And we have seen that the formula is very simple. And of course, you may get a question on perpetuity. Just put the payment which you get per year divided by the interest rate and you get the value of the perpetuity. So, okay, let's take this question. This is from page 4.36 of the study material. Quickly, let's take, and then we will see the CAGR and complete. So we are taking this question from page 4.36. So Ramesh wants to retire and receive 3,000 rupees in a month. So he wants a pension of 3,000 rupees per month. Okay, be careful, it's per month. Now he wants to pass the monthly payment to future generation after his death. So even after he's dead, he wants to give this 3,000 rupees monthly payment forever to his son, daughter, and so on. So it is the hint is it is an annuity with indefinite life. So the given case is a perpetuity. Okay, fine. Now he can earn an interest of 8% compounded annually. He is getting an interest of 8% compounded annually. Okay. How much will he need to set aside to achieve this perpetuity goal? So how much money does he need so that he can receive 3,000 rupees per year? Okay. Now, here the question, please note, is that he is receiving 3,000 rupees a month. The annual interest rate is 8%. The annual interest rate is 8%. But since the interest rate is 8%, it is annual. 8% compounding is annual. So I have to find the monthly rate. Okay. So what I will do is I will try to find the monthly rate because his payment is monthly. He wants a monthly contribution of 3,000 rupees. So what I do is 8% means how much? 0.08. Okay, so I write 0.08. This is annual. So per month, how much will it come to? I will write 0.08 divided by 12 because there are 12 months in a year. 0.08 divided by 12 gives me, let me just do it up, 0.08 divided by 12, 0.0067. 0.0067. This is what? This is my interest. This interest on a monthly basis. Okay, but this is 0.0067. I have taken decimal here and I have calculated the decimal rate. Now we have to find the present value. Present value, you know, is very simple. We saw that the payment which you want by the interest rate. Very simple. Here the payment is 3,000 per month. And the interest rate which I'm getting per month is 0.0067. Sorry, 0067. So what is the value? Let me calculate. 3,000 divided by 0.0067. I'm getting 4 lakh 3,000 by 0.0067. Let me just do it. Yeah. 4,47,761. Okay, just a sec. I think 0.08 by 12. Let me check. 0.08 divided by 12. 0.0067. 0.00667. We'll take 667. 0.006666 continuously goes on. So 667 up to 1, 2, 3, 4, 5 places. And so the payment will be here 3000 divided by 0.00667. So if I take that, it will give me a more precise answer. So 3000 divided by 0.00667, that gives me 4,49,775. So almost 4,50,000. 4,49,775. If you invest, please see the implication, please see the meaning. If you invest this money at the rate of 8% compounded annually, then every month you will receive 3,000 as pension, or every month you will receive a cash payment of 3,000. Okay, this is what it means. Right, now we go to the last one, growing perpetuity. In case the perpetuity grows, then the formula is just a small difference. In case the cash flow grows at a constant rate. So here we are assuming that you are getting 3,000 rupees as pension per month, or 30,000 rupees or 20,000 rupees as pension per year. But if it grows at a fixed rate, say the rate is 2%, say the rate is 3%, then what will happen? So in case of a growing perpetuity, so if it is a growing perpetuity, that means it is a perpetuity, but the cash inflow is growing. So I write growing perpetuity. In case of a growing perpetuity, the present value of that corpus will be very simple. The payment which you receive, okay, which grows in fact, divided by the interest rate minus the growth rate, I minus G, where I is the interest, G is the growth rate. Now you have not done APGP. I think it will be taken up later. So this is nothing but an infinite geometric progression, infinite GP series, and therefore the growth rate G, right, is always less than the interest rate. Right, if the growth rate is more than the interest rate, it will not be an infinite GP series. Therefore, always remember, this is nothing but, I'll just write, this formula is derived from an infinite GP series. Okay. So what do we get? Let's take an example. A very simple example is given in the study material. Discount rate is 7%. So let's just quickly solve the problem. Discount rate is 7%. It's given. How much would you pay to receive rupees 50? So the payment you want to receive is rupees 50 every period, but the 50 rupees will grow at 5%. It will grow at 5% per annum. So first year you get 50 rupees. Next year you get 5% of 50 as an increment. So you get 105% of 50. Okay. Next year you get 105% of that increased amount. So it goes like that. If you want to get this type of cash flow stream, then and assuming that the growth rate or the discount rate is the interest rate is 7%, right? So interest rate I equal to 7%, and the growth rate is 5%. So this is G, and interest I is 7%. What will be the amount which you must keep aside? So that means what? What should be your investment amount? So that you earn 50 rupees on in every period, which grows at the rate of how much? 5% per annum, forever. Right? Infinite GP series. Right. So what we do is, here the formula, the present value amount is equal to, very simple, you put the payment is how much? 50 rupees. You put 50 rupees here. I is the interest rate or the discount rate. This is 7%, so it is 0.07 minus growth G, 5%, 0.05. So it gives you 50 divided by 0.02. That is, it comes to 2,500. So if you put 2,500 in an investment where the interest rate is 7% and the growth rate of the cash flow will get 5%, then the starting payment will be 50 rupees, and then it will go on increasing at 5% every year. Okay. Okay, the last concept, of course, we take up is net present value, which is something we have already discussed, present value and the net present value. So it's very simple. Net present value means the present value of cash inflow minus the present value of cash outflow. PI means cash inflow and CO means cash outflow. Now, say a situation is like this, that you have a machine, right? You pay the cash, total cash outflow. You buy the machine at 5 lakhs. Okay, you buy the machine at 5 lakhs today, down payment. So cash outflow is 5 lakhs. You get some benefit every year from that machine, and the present value of all the cash inflow from the machine is 4,90,000. Should you buy the machine? My cost is 5 lakhs, and the present value of all the cash inflow, the benefit I get from the machine throughout the life of the machine, okay, till the machine becomes zero, full life, I get 4,90,000. Is it advisable? Answer is no. Why? Because here the net present value, NPV, is equal to, the formula is present value of cash inflow, that is 4,90,000 minus 5 lakhs, because 5 lakhs is present value of cash outflow. This is minus 10,000. That means it's a loss. I am paying 5 lakhs today, and the benefit I am getting over 5 years discounted back to today's terms is 4,90,000. It does not make a sense. It is economically not feasible. So NPV cannot be negative. If NPV is negative, you cannot accept that business proposal. So the rule is very simple, that NPV should always be greater than equal to 0. Otherwise, you should not accept the project. So please note, NPV should always be greater than equal to 0. It has to be positive. Otherwise, if NPV is equal to 0 or NPV should be more than 0, then only you accept that business proposal, then only you accept that project, otherwise not. So this is called the decision rule. Okay, decision rule. That means if you, simple, if you invest 20 lakh on your MBA, you're investing 20 lakh rupees on your MBA, 20 lakh. Okay, let me write 20 lakh. And you will be working for the next 10 years, right? Your total earning, present value discounted, is 18 lakhs. Should you go for the MBA? MBA, no. Because your cost is 20 lakhs, but the value of return which you get is 18 lakhs. But if you spend 20 lakhs on your MBA and you earn over a period of time 40 lakhs, yes, then it's good. So NPV must always be greater than equal to 0. So this is the concept of net present value. Okay, right. Good. Many of you are understanding and writing, so it's good for me to see that you are all understanding and you are able to see how things go. Now we go to the last 2 points of nominal rate of return. So we have done the leasing part. I'm cutting it out. Bond valuation done. Capex done. We take the rate of return now, nominal and real, and then, yeah, questions also we have done, and then we will close with the CAGR. Okay. So now we take what is nominal rate of return and real rate of return. Now I have discussed this, so we'll just discuss in just a few moments. The nominal rate of return minus inflation gives you the real rate of return. Now, yesterday I was discussing in the last session, say the interest you earn from an investment is 8%. 8% is the return which you earn. So this is the nominal return. Nominal means the return which is guaranteed or which is say communicated to you by that particular company. So it's a bond. So it's a debenture of a company. They are giving you 8% return. That means if you invest 100 rupees, you will get 8 rupees as interest every year. Simple interest. No compounding, simple interest. Fine. But the inflation, now I have discussed about inflation in last 2 sessions. I hope it's all clear to you. Inflation is the general increase in price. So if the inflation is 5%, then what will be the real rate of return? So nominal rate is 8%, inflation is 5%, so real rate of return is 3%, 8 minus 5. So always remember the real rate of return is equal to what? The nominal rate minus inflation. That is why we have to keep in mind whatever shares, debentures, bonds, public provident fund, mutual fund, wherever you invest, the return you get should be more than the inflation. That means your real rate of return should be more than 0. It must be positive. Say, for example, Senior Citizen Savings Scheme, they offer 7.4%, SCSS. If you see PPF offers 7.1%. Okay, bonds on an average, they offer 6.5%. So if the inflation is 6%, fine, then I am getting something more. But if the inflation, the way fuel price is increasing, I was giving an example, if the inflation becomes 8% and the return I get is 7.4%, then it does not make sense. That means my real rate of return becomes negative. The cost, inflation is 8%, I am earning 6%. So what? I'm incurring a loss of 2%, right? So therefore, this is absolutely important, and otherwise you will get a simple question on this part. Maybe they will give you the nominal rate of return and they'll give you the inflation rate. They'll ask you to calculate the real rate of return. The last point is the compounded annual growth rate, and this is used, compounded annual growth rate is used to find what is the annual performance of companies, and it can be the growth rate in terms of revenue, right? CAGR. So it can be the growth rate in terms of revenue, or it can be the growth rate in terms of profit. Okay, but it is compounded annual growth rate, so it is compounded annually. And the formula is, say, it is given, say, let me take the example given in the study material. So say, for example, the 2013, let me take this example from the study material, page 4.39. So say 2013, the revenue of a company is 100. 2014, it is 120. 2015, it is 160, and 2016, the growth has become 210. So if you have to find out what is the compounded annual growth rate, so what we do, we are taking, say, 3 years, and we take for 3 years. So let's take the figure of 2016 and take 2013. So 3 years, 2014, 15, 16, 3 years. So the CAGR calculation will be like this. CAGR calculation formula is, you put the value of the last year, so I write 210, divided by the value of the first year, which is 100, to the power 1 by the number of years. Since it is 3 years, I will write 3. So it is basically 1 by n minus 1. So it is basically the term n, Tn, the last value, divided by T0, the first value, to the power 1 by n, which is the number of years, minus 1. Okay, a small formula. So if you, of course, here you have to use log table, and if you calculate, if you break it up, because you have to the power 1 by 3, so suitable tables will be provided. So once you calculate, it will come to, from the study material, 1.2774 minus 1, that is 0.2774, and that means 27.74%. That means the compounded annual growth rate per year has been 27.74. Okay, so this is how we prepare the CAGR, and CAGR is having a lot of applications. The first is, we have to find out, now if you, as a chartered accountant later on, if you work in the area of investment management and finance, you have to find out the average return from investment funds. You have to compare the performance of 2 mutual funds, 2 investment options. So the one which has higher CAGR will be better. Okay. Plus, you may have to compare the performance of some shares in the last 5 years, like say performance of share 1, share A. We have done it and we have got CAGR 27.74. If I do another calculation for 3 years, 2013 to 2016, for another share, say B, and if I get a CAGR of 32%, that means CAGR of B is higher than CAGR of A. CAGR of A is 27%. That means share B is performing better. Higher the return, higher the CAGR, the better is the investment, the better is the share, the better is the profitability. So CAGR is also used not just for historically looking at the past year's performance, but also to predict future performance of shares. And this helps a lot in the calculation of risk and return from any investment. Right? So friends, with that, we will wind up. We started with the time value of money. Then we discussed about simple interest, compound interest. We have done a lot of problems from exercise 4B, 4C, 4D, and the AQB. I have taken past year's questions, and we have discussed about effective rate of interest. We did the problems. Then we looked at annuity. Annuity is of two types, annuity regular and annuity immediate. We did both the problems. Then we looked at present value, how to calculate the present value. We also learned how to use the present value factor which is given and the annuity factor which is given, right? Always remember the annuity once again is the cash flow into 1 plus I to the power n minus 1 by I. This is within bracket. This is the annuity. And if this amount is given, this entire value is given, then you just need to multiply the cash flow with the value, right? So annuity regular, annuity due. Then we had discussed about sinking fund. Today we started with the future value, present value concept. Then we looked at applications, leasing. We did numericals to find whether leasing is better or buying a machine is better. Then we discussed about capital expenditure, net present value, the bond valuation, how to find the price of a bond. And thereafter, we looked at perpetuity, which means an annuity which continues indefinitely till future. And if the cash flow which you earn in case of a perpetuity increases every year, then we call it a growing perpetuity using infinite GP series. We saw the formula payment divided by I minus G, where payment is the amount, P is the payment which you get every year, which grows. I is the interest rate and G is the annual growth rate, but I and G should be in decimal terms, same term. And finally, we have looked at compounded annual growth rate and the applications of CAGR, right? So this was one of the biggest chapters in mathematics, and we could complete it, of course, taking extra time beyond 4 o'clock every day so that the maximum number of problems can be covered and discussion. Plus, I've taken questions from many of you to discuss and simplify the entire process so that you understand. Look at the video again if you fail to understand any point, and please remember the core formula: simple interest, compound interest, annuity regular, present value, future value, compounded annual CAGR, compounded annual growth rate. And always remember that the net present value from any project has to be positive. Otherwise, we cannot accept that project. We cannot accept that business proposal. So friends, with that, thanks a lot for your patient hearing, for working out with me. Many of you are writing the answers, and for all your efforts. So we will meet next time with the chapter permutations and combinations, and that's how I will be completing my portion for the mathematics part this month. And please do practice the problems, and as many as possible we have done it here, but I hope you understand and appreciate the time limitations. So please go on practicing as many as possible, and please do remember the formulas. So till the time we meet, thank you, bye-bye, and take care.